Hey everybody, what we're going to be taking a look at in this video, probably two videos, is going to be a BC calculus concept known as partial fraction decomposition and long division. These are going to be advanced integration techniques that you may be assessed on an AP exam at some point. And that's what we're going to be taking a look at now is how do you do partial fraction decomposition and how do you do integration with long division. Now, previously in calculus, when we had something that was relatively complicated to try and integrate, we would use a method called U substitution. And U substitution essentially is where we try to find something that's more complicated that if I take the derivative of it, I'll find it somewhere else in the problem. And you can see that very clearly in the integration example here is if you take the derivative of the denominator, you get the numerator. Well, in some examples, these rational functions that we have, for example, U substitution won't work because if I try to take the derivative of anything, so let's just take a look at this problem here. If I take the derivative of x squared minus 1, if I try to take the derivative here, that's going to give me 2x, which does not match what I have in the numerator. And it would be the same thing with the other examples. If I try to take the derivative of x squared minus 7, I do not get anything that matches the numerator. And in the last example, if I try to take the derivative of the numerator, the more complicated piece, I get 9x squared, which in no way comes close to matching what I have in the denominator. So in certain circumstances, U substitution simply doesn't work. Now, the two techniques that we have for rational, I'm sorry, not for rational, but for whether I need to do long division or whether I need to do partial fractions, the term is based on what the higher degree is, where it's located in the fraction. Okay, so here, if you're reading what it's telling you, for proper rational expression, the degree of the numerator is less than the degree of the denominator. So that would be like saying, say, like something x over something x squared. And that's where I would have to use partial fractions. But if I happen to have an improper rational expression where the degree of the numerator is larger than the degree of the denominator, so go back to that x cubed term over the x term that you saw on the last slide. And that's when we would have to use some kind of a division technique, either long division or synthetic division. So if I have something that looks like this, where the degree of the denominator is larger than the degree of the numerator, that is an example of where I can use a proper rational expression. This, I should say, is a proper rational expression. And so here I would do partial fractions. Okay, that's really the clue that's letting me know that I need to use partial fractions here, because it's a proper rational function as opposed to an improper one, meaning the degree of the denominator is higher than the degree of the numerator. And the term that we use for it, so these here on the right side, those are the partial fractions, and that's what it's referring to here. This is partial fraction decomposition. And really the meat of this lesson is really going to be showing you how do you get those -1 and the +1 numbers in the numerator. And it's really, I think the method I'm going to demonstrate is going to be pretty straightforward, hopefully. Other methods that I've seen are going to ask you to try to create system of equations, things of that nature. And I really think that overcomplicates things a little bit. So here, this is just general information for you to have for your own purpose, for your own reference. The denominator, really essentially what we need to know in red is that we're not going to see something that has non-repeating linear factors in your calculus class. So here, and let me see, hopefully they didn't give us too much work here. And then here what they're showing you is that to begin the process, we need to split the denominator. Okay, so factor the denominator if you can. Okay, not every factor, not every denominator is going to be factorable, but let's say that we have a denominator, and this denominator would clearly have been a quadratic expression because we factored into two binomials. And we're going to say, okay, well, how do we figure out what those A values and B values are going to be? Well, it's like I said, it's a relatively simple process. So let's do A. Okay, this is the process that I'm going to do to find A. What I'm going to do is I'm going to say, okay, well, what is the solution of A's denominator? So if I take A's denominator, which is x minus 5, and I set it equal to 0, well, that's going to give me x is equal to a positive 5. Okay? And what we're going to do is we're going to take whatever that solution is, and we're going to use the other expression, the other fraction, to figure out the value of A. Okay? So I would take that 5 and I would substitute it in where I have the value of x in the expression. So looking at the numerator here, this is going to be applied to both the A term and the B term. I don't have an x value there, so I'm going to just take the numerator and put it as whatever it is. In this case, it's a 1. And now I'm going to take that solution of 5 and I'm going to put it in the denominator with the 2, and that would be 5 minus 2, giving me a 1/3. And this would be the number that I would substitute A with. So now let's try B. And the process is going to be pretty identical to what we would do for what we did for A. So let's look at B. So again, I'm going to look at the denominator of B, which in this case is x minus 2, and I'm going to substitute it, or I'm going to set it equal to 0. So here I'm going to get x is equal to a positive 2. Well, because I'm trying to find out what the value of B is, I can't actually use the B denominator. So I'm going to look at this ratio here to find B. Now again, whatever the numerator is, I just use the numerator with whatever I was given to me. In this case, the numerator is a 1. And I'm going to substitute the 2 anywhere I have an x. So in this case, I'm going to say 2 minus 5, which would simplify to be 1 over negative 3. And that would be the number that I would substitute for the A value, I'm sorry, for the B value of the expression. And that's what our partial fraction decomposition would look like. So here I would have, if we were saying that we were going to do this as an actual integration, I would say the integration of, let's do A, because that's obviously what was written first, we would have 1/3 over the x minus 5 plus, and I should have a dx here, plus the integration of the b component, which in this case would be negative 1/3 over its denominator of x minus 2 dx. And then, you know, if you really want to, in this case, because they're fractions, it kind of makes sense. You can pull out each constant from the numerator. So I would have 1/3 integral 1 over x minus 5 plus, and in this case, I'm pulling out a negative number. So we'll say minus the 1/3 integral of 1 over x minus 2 dx 2. And now we have something that's relatively easy to integrate. The ratio, the fractions that we have there, that's just the antiderivative of that fraction is going to be a natural log. So this would be 1/3 times the natural log. Oops, I don't know why I'm saying LIN. It's just natural. Oops, nope. Natural log. And we put the expression x minus 5 like so, minus the 1/3, and the antiderivative of that ratio will be another natural log of x minus 2. And because this is a indefinite interval, we say plus a constant, and that is as far as we would go. That's what we would do for partial fraction decomposition. And I know the examples that you have in your notes don't ask you to work the whole thing out, but that's essentially what we would do. So now that I've demonstrated essentially one problem for you, feel free to go ahead and try and pause the video and see if you can take what I showed you in that last example to do partial fraction decomposition with this example. So assuming that you've done it, or even if you didn't do it, that's fine. Let's go ahead and kind of, work this guy out here. So what I'm going to do first is I'm going to factor the denominator. So factoring the denominator is pretty easy because that's the difference of two squares. So that would give me 1 over x plus a 2 and an x minus a 2. Okay, dx. Well, now what we're going to do is we're going to do that partial fraction decomposition, where we're going to separate the two factors of the denominator into two separate fractions. So I'm going to say a, and over the a term, we're going to have the x plus 2. Oops. And I don't really need parentheses here. We'll just do x plus 2. And then we'll say plus the b term. And a and b are completely arbitrary. If you want to use something else or just leave them blank, that's perfectly fine. And we'll put the other factor from the denominator, x minus 2. And if you want to, you can separate them both with an integral and see what we get. So let's find a. So let's pick another color to find a. So what I'm going to do is I'm going to take the solution of a's denominator, which in this case, the solution of a's denominator, and let me restart this. I don't want an equal sign here. Let's do a colon. Let's take the solution of a's denominator, which would be a negative 2 in this case, and we're going to use the this ratio here with the b term to actually find out what a is going to be. So I'm going to take that 2 and I'm going to substitute it anywhere I have an x. Now, the numerator is always going to stay the same. The numerator, pardon me, the numerator is just the numerator, which in this case is 1. So I'm going to take that negative 2, substitute it for x, so I'm going to get negative 2 minus 2, which simplifies to be negative 1/4. Well, that is the value of a. That is, I'm going to take that number and I'm going to stick it here and substitute it for a. Well, now let's do b. Let's find out what b is going to be. So b, repeat the same process. B's denominator, the solution of that, will be x is equal to a positive 2. So now I'm going to kind of look at this ratio here, that expression, that fraction, to figure out what the value of b is actually going to be. So again, the numerator is just the numerator, which is a 1. And I'm going to take the positive 2 and substitute it into a's denominator. So I get 2 plus 2, which will give me a 1/4. And that's the number that I'm going to substitute here for b. And when I do, we're going to get, and let me go back to my original color here. I think I was using red. When I substitute here, I'm going to get the indefinite integral of a, which in this case would be a negative 1/4 over the x plus 2 dx, plus the indefinite integral. And now we're going to look at b. So b became a positive 1/4 over its denominator of x minus 2 dx. And now we, particularly because these are fractions, we want to go ahead and pull them out, although it's not strictly necessary, because if I take the antiderivative of the way they are now, is still the numerator natural log of the denominator. So this will become negative 1/4 times the natural log of the x plus 2 plus the 1/4 times the natural log of the x minus 2. And because we're doing the indefinite integral, we say plus c, and there is your solution. So hopefully this is going to go fairly quickly. I think most of you are going to be able to pick this up relatively easily, but if you're not, again, feel free to drop me a line and let's talk about it. Again, feel free to go ahead and pause this video in this example and see if you're able to figure out what the final integration with partial fraction decomposition would be on your own. And presuming that you've done that, we'll go ahead and start working it out and just see how you're doing. So we're going to start off first by simply taking the denominator and factoring it. So the numerator is just the x minus 11. And the denominator, when we factor that one, we're going to get an x minus a 5 and an x, not minus, or I started to write a plus, but it's not, an x minus a 2. Okay, so now this is where we're going to kind of break it up into two separate fractions. Okay, so here I'll say the indefinite integral of a over the first factor, x minus 5, plus the b over the second factor, x minus 2. And we're going to repeat the process that we did in the last two examples and see what we get. So let's kind of take a greenish color here. Let's do a here. So I'm going to take the denominator of a and find its solution. So the x minus 5, if I set it equal to 0, x is going to be equal to a positive 5. So now I'm going to kind of look at this expression here and figure out the value of b. Now keep in mind, we are using the numerator still, and this is the first example where the numerator is not a number, it's an expression. Okay, so I'm going to take that number and I'm going to substitute it anywhere I have an x. So the numerator x minus 11 becomes 5 minus 11 over the denominator of b, which would be 5 minus 2. So simplifying this, I get a negative 6 over a positive 3, which overall simplifies to be a negative 2. And so that's going to be the number that I will substitute a with. And now let's do b and see what we get here. So b, essentially the same process. We take the denominator of b and solve it for x. So in this case, x will equal a positive 2. And I will use this ratio here in order to find the value of b, which is not going to be very difficult. But again, we use the same numerator. The numerator doesn't change. So I'm going to take that positive 2, substitute it for x, so I get 2 minus 11 over the denominator 2 minus 5. So simplifying each one, the numerator is going to give me a negative 9. The denominator is going to give me a negative 3. So overall, that simplifies to be a positive 3. And that will be the number that I substitute for b. So now, going back to my original color here, we can continue with our partial fraction decomposition. And in this case, we will have the negative 2 for a over the x minus 5 dx plus the integration of for b, so that would be 3 over x minus 2 dx. And now take the antiderivative of each piece. Again, this is going to be a relatively simple one with the ratios. So we're going to wind up with a negative 2 times the natural log of x minus 5 plus a 3 times a natural log of x minus a 2. And because it is an indefinite integral, we have to add a constant at the end. Okay, and I believe we got a couple more examples, so we're going to try and go through them quickly. I do want to get partial fractions on one video and long division on a separate video. But again, feel free to go ahead and try to work this problem out on your own ahead of me and see what you wind up getting. I'm going to go ahead and start working it out, presuming that you've paused the video and tried attempting the problem on your own. So the numerator, even though we can factor it, it's really unnecessary to factor the numerator. Really, the only thing we need to do is factor the denominator. So I have 3x plus 6 in my numerator over a factor denominator of x times x plus 3 dx. Okay, so now we're going to break this up into our partial fractions. All right, so I'm going to say partial fraction, and we're going to have a over the x. plus the integration of b over the x plus 3. So again, we're going to set each denominator equal to 0 and see what we wind up getting. So let's do a in this greenish color. So a's denominator, if I set it equal to 0, x equals 0 is just x equals 0. So again, I'm going to look at this ratio here to find the a value using the given numerator of the problem. Okay, so substitute 0 anywhere you have an x. So this becomes 3 times 0 plus 6 over, the denominator here is going to be 0 plus 3. So that simplifies to be just 6 over 3, which would be a 2. So that is the a number. Oops, going a little too high on my arrow here. So here is my a number. Arrow, arrow, there we go. And let's do b. We'll do that in blue here. So setting b's denominator equal to 0, you're going to get x is equal to a negative 3. And again, we're going to kind of look at this expression with the given numerator to find the value of b. So doing so, I'm going to get 3 times negative 3 plus 6 over negative 3 for a, or a's denominator, I should say. So simplifying the numerator, I get a negative 9 plus a 6. So negative 9 plus 6 will be negative 3 over negative 3, which simplifies to be a positive 1. So that's the number that I will substitute for b. So now we can continue with our partial fraction decomposition. And again, I don't think that this is strictly super challenging of a concept, but we'll go ahead and finish off the examples that we have here. So here, replacing a with the 2, I'm going to get 2 over x, in this case, dx, plus replacing the b with the 1, I'm going to get 1 over x plus 3 dx. So now we'll take the antiderivative of each ratio, which again is pretty straightforward at this point. Here we'll get a 2 times the natural log of x plus 1 times the natural log of x plus 3 plus our constant for our indefinite integral. And our last example here we're going to take a look at. Now here, again, this is a proper rational function because the denominator is larger than the numerator. And the numerator does not need to be factored. Okay, so we will start by saying this will still be x squared plus 12x plus 12 in the numerator. Factoring the denominator, I will say x times, and if I factor out x, I'm going to have x squared minus 4, which would be an x plus a 2 and an x minus a 2 dx. And now in this case, this one's going to be a little bit different. We have to have 3 partial fractions that we're going to be that we have to look at, because in the denominator I have 3 factors. So let's break this up here. So we'll have an a over its denominator of x. I'll have a b over its denominator of x plus 2. And I'll have a c over its denominator of x minus 2. Now the difference between these, or this particular example and the ones that we've already seen, is that we can't just look at one ratio. We have to look at the entire problem as far as what, well, let's just go ahead and work it out, and I think it'll be a little bit easier to see when we work it out. So let's do A, all right? So let's do A in this kind of purple color, okay? Now a, in this case, if I set its denominator equal to 0, I just get x is equal to 0. Okay. Now the numerator is the numerator. It doesn't change. Okay. So I'm going to take the 0 and I'm going to substitute it anywhere I have an x in the numerator. So that would be 0 squared plus 12 times 0 plus 12. Now what goes in the denominator? Well, what goes in the denominator is whatever I did not use from the denominators already, meaning I have two denominators that I have to plug in the 0 for and multiply them together. Okay, so I'm going to take the 0 and I'm going to plug it into the b denominator, so that'll be 0 plus 2. And I'm going to take the 0 and I'm going to substitute it into the c denominator, which would be 0 minus 2. And now we're going to simplify it. So overall, the numerator works out to be a 12. Uh-oh, didn't mean to do that. Hit something on my keypad here, or my taskbar. So the overall numerator is just going to be 12. So 0 plus 2 is 2, and 0 minus 2 is negative 2. So positive negative 2 give me a negative 4. So this overall simplifies to be a negative 3. And that's going to be my value for A. All right. So let's do B and see how we pick up on this one. All right. So for B, if I set B's denominator equal to 0, that's going to give me x is equal to a negative 2. So I'm going to substitute the negative 2 into the numerator. Negative 2 squared plus 12 times negative 2 plus 12. And it's going to be over the denominators that we didn't use. So the denominators that I didn't use to get the negative 2 are this x here and this x minus 2 here. So both of those are going to be in the denominator to find the value for b. So I'm going to substitute a negative 2 for the x denominator for under the first fraction. And under the third fraction, I'm going to substitute a negative 2 there. So it'll be negative 2 minus 2. So simplifying the overall numerator here, we're going to get a negative 8 over, I think the negative is going to be in the denominator, however. Let me go ahead and just double check my arithmetic here. So this will be a positive 4 plus 12 is positive 16 minus 24 will be a negative 8 in the numerator. Okay, so we do have a negative 8 in the numerator. And we'll have a negative 8 in the denominator also, so this simplifies to be a 1. So that will be the number that I replace the b term with. Okay, and something is feeling a little off here. So I'm going to pause for just a quick second and do this on my calculator and just make sure my arithmetic is correct that I did in my head. So hang on one second. Okay, so yes, I did make an arithmetic error here, and it's right here. Somewhere in my head, I just looked at the denominator and just multiplied negative 2 times negative 2 times negative 2, but that should work out to be a positive 8 because it'll be a negative 2 times a negative 4, so this will be a negative 1. Okay, so hopefully those of you at home are like, yes, I got it right, or, oh, silly Mr. Piercy. But anyway, let's go ahead and find C now. So let's do C in a brighter color and see what we wind up getting. All right, so for C, we set its denominator equal to 0, giving me x is equal to a positive 2. So I substitute the positive 2 in the numerator, which in this case would be 2 squared plus 12 times 2 plus 12 over, and we use the denominators that we didn't get the solution from. So these two denominators right here specifically is what we're going to be looking at. So we will take the 2, substitute it for the x from the first example, or from the first fraction, and then take that 2 plus 2 here in the second fraction that we see. And so the numerator in this case is going to work out to be a 40 over a positive 8, which is going to simplify to be a positive 5. So that 5 is what I replace the c with. All right. So hopefully you guys are keeping up with me here, but now let's go ahead and, or hopefully because I think the explanation takes way longer than the work actually does, and the work on this is really simple. So for the first fraction, we're going to get a negative 3 over x dx. Then we're going to get another one where we substituted the b, and that'll be negative 1 over x plus 2 dx. And then the third one will be the 5 over the x minus 2 dx. And now we can take the antiderivative of each one, and I will wind up with negative 3 times the natural log of x minus 1 times the natural log of x plus 2 plus 5 times the natural log of x minus 2 plus our constant c. And that is going to conclude the examples that we have for partial fraction decomposition. So we're going to go ahead and stop this video here, and we will do a second video for long division. So thanks for watching. Take care.